Good afternoon, everyone. So, our second panel is about to start. We will be talking about distributed machine learning system from edge intelligence to cross-chain learning. And we have our moderator, Naman from BigBrain, and three of our speakers, Sriram from the University of Texas at Austin, Mori from Heisenberg Networks and Associated Professor at TMU, and Salman, the co-founder of ChainOperaAI. AI. So, welcome, guys.
And a professor at USC.
Oh, awesome. Yes.
Cool. Hello. Hello? Hello? It works? I don't think it works.
Hello, hello, hello.
This
Yeah.
isn't working.
Hello?
Yeah, that's what it is.
Hello, hello.
Hello.
Well, let's get started. Thank you guys all for being here. You guys are pretty esteemed professors all over the country, so looking forward to this discussion on distributed ML systems. I guess to start, it'd be good to get a background for the rest of the audience in terms of what are the main components of distributed machine learning, kind of go over into parallelism and then some of the constraints that we have to look at in order to achieve something in a distributed system.
Okay. Because it's a small group, can I just get controversial? Distributed systems is generally a pain in the behind. You don't want to distribute anything unless you absolutely have to. I'm distributing because I can launch a token and make a profit isn't the right reason to distribute anything. A distributed architecture needs to have not just a good reason for the architecture, but also a very well thought out architecture. You can distribute things and make a pig's breakfast of the whole thing, which is very common, actually, especially in AI. To say I'm going to distribute something, throw a bunch of things all over the place, and then make a messaging meets coefficients, meets all types of malincentives, is not an uncommon occurrence. And so thinking through this extremely well is very important. On that, I'm going to turn it to my esteemed colleagues here to talk about why distribute and how they've distributed and why it matters. Let me turn it to you.
Thank you. I love how you started. There must be a motivation. If there is no motivation, just for the sake of having a distributed processing, that doesn't make sense, and that shouldn't be.
And a token makes me rich is not the motivation.
Yeah. Yeah, but I think from my perspective, I'm working on the data processing and engineering. And in our perspective, one of the reasons that distributed processing makes sense, particularly in the context of deep-end or edge computing, is the cost that you can bring much, much lower compared to, let's say, single processors. That's one thing. And for example, well, there is distributed processing. The other one is decentralization. The distributed processing is happening on the data level by Amazon and others because, well, one single computer cannot do the job and give you real-time process AI-ready data. That's kind of the question that is being solved. But the other question is that the decentralization, right? We are talking, okay, you know what? All the processor CPUs by Amazons are amazing. They do the job. They give me whatever I want at real-time rate. But how much is going to cost me? And of course, the other perks of the decentralization that I'm missing, the privacy of the data, the centralizations, and then of the data on one side. But the main motivation for me that I got actually to the decentralized processing, in addition to the distributed processing, was that, okay, you know what? Edge computing could be much, much, much cheaper. Of course, it comes at the cost of other challenges, verification, security, and other things. But if cost is one of the bottleneck that we can grow faster, decentralized processing can definitely solve it.
Very cool.
All right. Yeah, I think that was a great start, Sriram, that you had. Actually, all my life I have been working on distributed systems. Initially distributed communication, then distributed computing, now distributed machine learning. Maybe I have a little bit different perspective that distributed actually is great. Maybe a great example of it is internet and TCP/IP, right? It's scalable. So why do we use distributed? Because these systems are massively scalable. They are inefficient initially. We should appreciate it, right? But massively scalable. Now, where do we need the scalability? The number one need today is AI, right? Think about the scale of it. It's massive, right? It's going to be much bigger than the scalability we need for internet. So that's where I personally get passionate and what we are doing at ChainOpera to use decentralization, distributed for AI. Now, what is distributed? Compute, data, models, users, right? Soon, agents, right? So there is going to be there were maybe talks actually in this, I think, event earlier, billions of agents, right? So everybody is talking about in our ecosystem, we have thousands of and thousands of agents. What, for example, we are building at ChainOpera is a gateway to many agents. Like you see internet without a Google, you cannot use it. It's just a billion web pages. Google solves that. Right, so that's maybe another way to view, but as a segue, maybe that's what I'm passionate about on the role of distributed for AI and why we are doing it. But we can proceed with other questions to get more details.
Yeah, I mean, I guess my comments on that, like, if you look at computing, right now, the thesis in the Web 2 world around AI is that the bottleneck's around communication. If you solve the communication bottleneck, the next bottleneck is around compute. And the compute bottleneck is only going to be solved in a distributed system, which is why I believe we need to do the work and the research here anyways, while we solve the communication bottleneck in order to get access to long-tail compute, which is significantly more available in Web 3 than exists in Web 2. But kind of double-clicking on this, I'd love to kind of move on and dive a little bit deeper into what approaches you guys are taking or what approaches you think can be taken in order to even make distributed compute possible. Because obviously communication has been a very big bottleneck, and recently we've seen a lot of progress in the area. So would love to get your guys' thoughts on the progress that's been made.
Very cool question. Okay. So, and if you don't mind, I'm going first again, but would you like to go first? So I think innovation happens when bottlenecks keep switching around. Let me explain what I mean by that. Let's say a bottleneck is A. You go solve that, and it switches to B. And you go solve that, and it's back to A, and you solve that, and it switches to B. It's almost never that there is no bottleneck. By definition, there has to be some bottleneck that ultimately is being pushed further and further to improve things. And that is the beauty of what crypto has done. Again, I know I'm being recorded, and this is going to be a controversial statement, but I believe crypto is a funding mechanism for good innovation that makes communication, compute, proof systems, ZKPs so much better. And because each of these technologies is implicitly funded and enabled by crypto, each one of these changes where the bottleneck location is periodically. Another way of putting it is, communication bottleneck, great. What do? You try and reduce the number of messages to be sent using some clever summarization, proof generation technique, right? Or you make the communication network less floody. By floody means you just share everything. Find a way to make it more directed. I think that level of innovation is actively happening. And that is why you have 3 professors on the stage here and so many professors at this conference. Is because they go, oh my God, I've been doing this research, 20 years? Quite a long, decades. And here is an opportunity to take this research and in a permissionless way bring it to practice to solve a bottleneck problem to make somebody else bottleneck. That's my perspective. But
Yeah, please go ahead.
That's actually a very good point. I completely agree on the kind of statements. I like the idea that the science comes in when there is a bouncing around different challenges. But one thing that I believe it's been changed a bit is that there is no kind of dreamland that you said that you go there and then the problems or the challenges you're dealing with are all vanishes, right? So to me, what happens and the problems that we had and motivated us more toward the decentralization was that, okay, you know, we have the communication bottleneck, we have the processing bottleneck, but we can solve them at some level. Actually, that's what happened with the training. If we look at the ML ecosystem in general, from the data collection to processing to training to inference, which to me, I consider AI agent as an inference part as a machine learning person. For each of them, they have their own problems and challenges. And the challenges have been solved for many of them at some level, but it becomes the problem that becomes, and I think DeepSeek actually proved that that's just a kind of a problems becoming the bubble or a big challenge because there are centralized entity who want it to be. For example, maybe GPU was not and is not the challenge of building much, much bigger, smarter training models. Maybe the challenge is more architectural side as well. This is something that we moved from that centralized world to decentralized to say, okay, you know what, we can solve the communication problems. We can bring huge amount of idle CPUs, GPUs, being leveraged, monetization or whatsoever to solve some kind of, challenges there. But when we look at the other side, when it comes to the decentralization, I think there are new challenges that maybe we never thought about them there. So it doesn't mean that we are maybe even bouncing. It's more trying to solve one challenge, we get to another type of challenge. When I was a master's student, I was doing distributed processing for training machine learning algorithms, right? And my only challenge was that, okay, how to efficiently break a machine learning task into some subtasks that I can do them in parallel to build a model, right? There are, of course, you can definitely, comment on this, but I believe that now breaking the task is not the main challenge now. The question is that who's gonna do this task? Is it being done correctly? I never thought of it like 10 years ago, 15 years ago. Okay, should I care who's doing this job? But now we do care more about this. So these kind of challenges that actually comes as consequences of solving other challenges, I would say that they're going to be the main problems in the new kind of machine learning compute paradigm.
Very good. So now let me maybe give you specific ways we solve the problem, like at ChainOpera. Right, high level we can talk about it, but let's say, first of all, we talked about there is a lot of distributed compute, right? How people use centralized compute, let's say AWS, there is AWS Bedrock as a platform sitting on top of it, abstracts away, you submit your training job, inference job, you do what you have. What have we done? We have built our AI platform, ChainOpera Federated AI platform. This is similar to AWS Bedrock, but built for decentralized cloud. What is the underlying technology? You can do inference, you can do training, right? So then training, you have to think about what is gonna be the type of models. For example, we released the first example of a small language model that you can actually train on decentralized cloud without communication bottleneck. Why? Because for a small language model, you don't need to parallelize the model, which creates the communication bottleneck. So you have to smartly use the decentralized infrastructure. For inference, there is no communication bottleneck actually, right? Because as long as each GPU holds it, you can auto-scale and have endpoints scaling across many of them without needing to talk. So we have endpoints that do better than, let's say, centralized endpoints, let's say by Together AI, Fireworks, etc. And that's the power of decentralization. Then you go to data, right? There is massive data, you want to learn from that. How would I use that? That's where federated learning comes, right? Don't ship the data. Train from federated data, whatever you want to train model. And maybe third one, think about distributed models or agents. All of us may have agents, and that's what I was mentioning. We have our AI terminal mobile app. Think about it like a gateway to agents. Like similar way as you go to ChatGPT, maybe you see many agents or skills at the bottom that you can use. Now, our vision here is that through this terminal, every agent that partners become in our ecosystem could be skills that everybody could customize, could use, right? So through effective routing, discovery, right, you get entrance to a variety of agents or models to solve your problem, right? So that's how I think many of them are now doable, right? 5 years ago, this seemed very difficult, right? But I think we are at a point that we should not expect maybe through distributed training or decentralized training, we are going to build a 300 billion parameter model, right? That one, of course, you need GPUs in central rack connected by NVLinks, right? But a small language model, we have shown it's possible.
Yeah, so this is something I like to kind of think through on every panel I've been on so far, because generally speaking, on these panels, distributed and decentralized starts getting used interchangeably, and they're not, right? So given the distinction between decentralized and distributed training, what is the need for decentralized training? And philosophically speaking, why do we work in a world where we want decentralized trust assumptions?
Yeah, I can start. So typically, distributed is because you lack resources, right? So for example, maybe you don't have enough memory. You have to break your model to distribute it. Decentralization, to me, is there is an underlying economy, right, that requires decentralization. So what are the underlying economy? Data ownership, right? You don't want to give the data free to OpenAI, right? OpenAI is going to keep milking better and better agents, better models by learning what people like so they can be like human, right? But what do you get? Nothing. So that's number one. I think we want an economy. Currently, this economy in Web 2 is built by users providing the best content, resource providers, NVIDIA, the winner. We want to turn it upside down. Right? So it's kind of what we want is people who have the data, who are interactions, to be the winners of this economy. So that's the decentralization aspect. Then you can also think about it. There is other aspect of this economy. You own also a lot of compute, right? A lot of models running on my phone, right? So what am I getting for the reward for that? So I would say economy is the answer and the distinction. And I think right now in the world of AI, we see necessity for an AI economy, which is maybe empowering more humanity. And in the long run, if we are not part of this, right, this is a huge technology we will be left out. We don't want that.
Yeah, sure. So one very good point my colleagues made was that TCP/IP is technically distributed. And they're absolutely right. Technically, when we started with ARPANET, it was meant to be this distributed world that is architected by peer-to-peer systems all working together. But essentially, this peer-to-peer system, even though today is distributed heavily, is economically completely centralized, which essentially means that you're looking at a bunch of products, right, over here, each one of us, that is being monetized by everybody else. Well, some people. So the question is, as correctly attributed here to my colleagues, is how do you bring that paradigm back? And that paradigm is to combine distribution with decentralization in a manner that leads to much better attribution of who contributed to what and why that contribution matters and why it's not just a bunch of garbage going in. And based on that, making sure that the people who are to be compensated have a situation where they feel that they're actively part of a system that's making their lives better and everybody else's lives better. And that collective feeling today doesn't exist unless you're a big stockholder in Google or some of the other companies. Even then, you often don't have it. That is the goal of decentralization. Decentralization, I heavily agree, is less about actually the technology. It's more about incentives, because it enables these incentives in a way that was not possible before.
Thank you. I think the majority of aspects being covered. I just want maybe clarify something on the incentive. I agree that the financial incentives is really important, but there are other type of incentives that actually matters, right? The impact that you first, for example, your CAT scan image can make to cure cancer. you have to get the credit for that. Maybe it's not an incentive in terms of how many dollars you earn out of that research, but you actually contributed. And actually that's, to me, what bring more tangible importance of privacy. That, okay, see, your data is actually matters. So you have to keep it private. You own it and you should have it. And the other part on the decentralization is something I'm just trying to kind of, cover aspects that has not been kind of discussed, is a huge amount of untapped computation source out there that is in every single room. Many actually are here now, that they are not being leveraged efficiently. Instead, we are just building and paying more for something that, Amazon offers. This is actually was the motivation we started Heisenberg at the beginning, was that, okay, everyone in AI, if I ask you what compute actually make AI happen, everyone will say GPU. But the question is that, is GPU the only component we need? Do we need GPU for data collection? Do we need GPU for processing? No, we don't. We need it for training, we need it for inference, but for many kind of other phases, we don't need it. And there are 60% idle CPU all around the world. And no one leveraged these CPUs to actually make effective contributions to the ML ecosystems. And of course, whoever owns this CPU, they have to earn. So we started with this, okay, you know what? You just share your CPU. We are not in the GPU market. Your laptop, just give it to us. We use it actually to build very complicated data pipelines to deliver what matters to a training phase, to an inference phase, what any contextualized AI ready that needs. So that's kind of these untapped idle sources of compute. I think that's another kind of aspect of decentralization.
Thank you guys for your answers on that, but kind of moving on to a different sort of question a little bit. If you look at machine learning systems as we see today, firstly, I'd like to ask you guys, do you think scaling is what is essentially going to lead to AGI? Do we think we just continue to scale these models bigger and bigger and bigger, and essentially, after all the research that's come out, these models are still 95% sparse? And is that really the correct way to scale, or do we think that mixture of agents or mixture of experts, which can run on edge, will ever outperform centralized large language models?
Yeah, that's the one I'm thinking every day. So I think there are two views on that. Maybe to summarize, I think there is the maybe OpenAI view that you automate data generation, then you automate data labeling. After that, feed it to train the next model. So GPT-4, GPT-5, etc. Gradually, this system will eventually get better and better. The question where, nobody knows. That's a beautiful problem, right? But that will go, I think, to whatever you call it, one form of AGI. My prediction is maybe that one is going to be able to solve a lot of math problems. Why? Math doesn't need actually measurements, doesn't need humanity. You need somebody to figure out all the branches of the proof, analyze it very carefully to figure out which one is correct or not. Such a math will not discover new fields in math, but will solve many theorems, right? Because it can work days and nights. So in that sense, yes, I think that scaling will lead to some AGI. Is that the type of AGI? Maybe we feel a lot excited about it. Not much, right? Because I see a lot of maybe room in science that you need measurements, you need humanity. So that's why actually we are more passionate on the second form that you mentioned, right? Second form, I think, is about thousands of models. What can they do as a complex problem solver for your daily life, right? That would be maybe much more tangible and useful for everybody to use. For example, then you can think about, you have a bunch of agents, sitting around. What they can do, they can analyze all the news, figuring out what is the noise there, coming up with a trading strategy, execute it for you, create wealth for you. They can also do something on your health, analyze, figuring out what you are doing right, what you are not doing right, buy the things for you, push you as your personal assistant. So I think that's form of AGI, right? So it's kind of subjective, what you want to call that. I'm very passionate on that scaling. that there is humanity involved in it, is solving a lot of problems that we are struggling with, right? Not everybody can figure out how to do trading, or not everybody can figure out how to analyze the data, know what is happening in the world, etc. So that, I think there is much room for decentralized AI to push on that aspect of scaling, and maybe contribution matters a lot there. I think that's what Sriram mentioned, right? So we all want to contribute to make such an AGI possible.
There are a couple of questions in my mind when I want to answer this, right? First, what scaling means. Are we talking about the compute scaling, data scaling, or intelligence scaling? These are all, we are in different stages in each of these. And again, what's AGI? I like that you mentioned one form, and there are other forms. That's something that, for me personally, AGI is not well defined. Like that back in maybe 10 years ago, we were talking about big data, but there were many definitions, and everyone, as they were hearing, they were thinking of high volume data, but big data was not just that. The same for AGI, I believe that there are many definitions. But what I believe something that I can think for AGI is that, yes, there is one component of thinking process in AGI that become general enough that can do a lot of things. That requires a lot of scaling on the compute and, of course, intelligent data, not just data overload that at the moment we are in, the data that actually matters for bring the intelligence to that kind of model. The other part that is the actionability, right? They have to act upon whatever they think to become kind of, a complete model to me. And that part, we are way behind. We can actually build smart thinking models, but how smart they're acting, that's something that I think is maybe beyond what we have at scaling process at the moment. That's kind of, my opinion on this, yeah.
Very cool. Agree with both of my colleagues. I think it's all about dynamism. Let me explain what I mean. You can build large centralized model, distributed agentic platforms, as long as there is a deep degree of dynamism in how and to what extent these can incorporate ever-changing information and types of information. Those will tend to outlive and outlast others. And there's different types of dynamism in each of the aspects talked about here, whether it be on the data side, whether it be on the intelligence side, on the decision-making side. And each one is at a different stage of realization. Honestly, where we have really cracked the code is in what we used to call NLP. Everywhere else, we're kind of doing things which are smart, but still we have a lot of room to go. So, and data isn't just text. Yes, text is a great amount of data, but there is so much in this world that is data. What's coming off an airplane is data. How that incorporates and improves and dynamically causes either edge or centralized or both to improve over time is going to determine the winning formula.
Awesome. Thank you, guys. I guess kind of going into this agents and mixture of agents route, right? I think there's a distinction between agents and algorithms. And generally speaking, we've developed algorithms to do a lot of things at a very, very highly performant scale. How do you see AI playing into that dynamic going forwards, considering if you look at it today, most of these agents still lack in comparison to most algorithms that humans have developed so far?
Could you rephrase that?
Well, we've kind of come across this thesis that AGI is going to exist, and it's going to be able to solve a lot of problems for humanity. And what seems to be happening consistently across the space is that if you look at trading, for example, you have high-frequency traders that develop really, really good algorithms. And then people say, oh, we're going to build an agent to trade for us that accrues value and accumulates wealth. It's not nearly as good as the algorithms that high-frequency traders have developed. So do you ever see that paradigm shifting, or do you think agents is a way for the bottom, like the long tail of humanity to become a little bit smarter, whereas the smarter people are still developing something that's significantly smarter than agents?
Okay. I do have an opinion here. So if you don't mind, let me share my opinion. See, what have we humans done over the years? We observe the world, right? And by observing the world, and occasionally an apple falls on somebody's head, we develop an equation, right? And we say, this is a representation of the world, right? And this representation sometimes is really, and I'm sorry, I'm going to use the word cute. It's so beautiful, right? E is equal to mc squared. Oh my God, it's so beautiful, right? And we all badly want this one governing equation that explains all data, right? Explains everything, explains the universe. But we still do not understand a vast amount of the universe. We understand when two things gravitationally behave around each other. When it becomes three, we lose it, right? The point is, yes, it is hopefully possible that we learn so much about physical, biological, chemical, and other real-world properties to be able to capture everything in finance, whether it be Black-Scholes, capture everything in fluid dynamics, whether it be Navier-Stokes, so on, in a nice manner around which we can build algorithms or explicit algorithms. But I don't know if that's going to happen. I think in reality what's going to happen is there's going to be an implicit representation of the world. And that implicit representation of the world is going to grow and grow and grow. It's going to be one bunch of giant spaghetti logic, distributed, potentially, very, very decentralized, potentially. And that is going to encompass our understanding of the world, because we just don't understand the world to the level of accuracy or the level of detail explicitly as we'd like to.
So I guess just to clarify a little bit based on kind of that response, do you guys see agents replacing humans in terms of what they do on a day-to-day, or do you see agents augmenting humans to create better and better algorithms?
Okay, that makes more sense. Okay.
But maybe I can answer maybe first part, a little bit different perspective. I think algorithm is a piece of software you write sitting somewhere. It can execute, right? The problem with that is, like many of us may have idea to writing a trading algorithm. And in fact, how do you know? Maybe this is even doing better than a hedge fund's algorithm. The problem is we don't have the tooling, like in a hedge fund, this algorithm is running in a very complex ecosystem, collecting the data, doing the trading, operating it. That's the part that we are missing, not writing the algorithm. So now why agent changes that? Agent may just run the algorithm, simplify this, but it has a lot of API tooling, right? So it goes on Twitter, gets all the pieces, summarizes it, feeds to the algorithm. Then comes up, does the sentiment analysis, comes up with a set of maybe stocks you need to buy. Then execute it for you. I think that's what we are missing, the tooling. So that's what makes me excited about the agent, is not necessarily, what you were saying is also correct, meaning that typically if you don't have an underlying model, machine learning is gonna do better, right? Because we don't know what is the underlying model, let's just learn it from the data. That's true. But I think agents give us these exciting tooling capabilities that ordinary people can't build it by themselves, right? So much skill needed, but right now we make it through our community very easy to do. Somebody is gonna, like there are Web3 companies, they give you API for tweet data. Some analyzing what is happening on the markets, right? So all of those, putting it together, that's the excitement of, I think, decentralized AI agents. So we should embrace that, I think.
Okay, my short answer, I hope. If it means that I don't need to work and get paid, I hope. That's the short answer. But I think one overlooked components here is that we are all thinking about the potential of what AI can do for us, right? Replace all the jobs. But we don't think that the nature of the jobs also changes. Yes, maybe it becomes, we see the potential, maybe an AI agent can do the day trading like me. But does it mean that 3 years from now, day trading is the job human focus on? It's like the time that when we had a web doom, like when everyone think that, oh, you know what, all these jobs will disappear and everything will be replaced. What happens to me, back into the first version of your question, I believe that, yes, there are replacements. Depends on how much of this potential being released that we think it has. And the other part is that we get smarter on top of that, which means that even the jobs that we'll see in a couple of years are not the one that we see now. I'm sure that in this room, maybe 10 years ago, if you asked that, what's your job? And the person said that, you know what, I'm a verifier on the chain. No one would think that there is such a job or there is such a kind of role in the world, right? But this happens. So I believe that this part is something that I don't know the answer, but I'm sure that there is a new paradigm of jobs that AI might not be able to even replace.
Well, thank you guys so much. I think we're at time, but I appreciate your guys' time and answers.